Hi, it's my great pleasure to give you the presentation about our MSBD5001 group project, Expedia Hotel Recommendations. Alright, let's get started. We have 6 members in this project. And this is today's presentation's outlines. We have 6 sections to present. So the first section, background. When asked what the most overwhelming matter is in travel planning, many people say that there's nothing worse than picking a cozy hotel out of hundreds of or even thousands of choices. With the data provided by Expedia, an American travel booking website, our group hope to apply the big data technologies we have learned in this class to offering personalized hotel recommendations to travelers. In this project, we apply machine learning models such as random forest, XGBoost, and SGD. We also adopted the collaborative filtering method using the technique of Spark. We'll give the details of our project in the following sections, including data description and pre-processing, and the details about machine learning and the collaborative filtering method, and then we'll give a conclusion about our project.
Hi, I'm Changming. I will introduce the second part of our group presentation.
Let's go through the data description and visualization part. Firstly, I will show you the data source and structure. The dataset were obtained from cargo competition, Expedia hotel recommendation. These data are randomly selected from the Expedia database. The training set contains about 37 million records from the year of 2013 to 2014. The test set stores 2 million reservations from 2015. The training set and test set share most of the feature. Each row of the dataset contains 24 columns, which are the research parameters produced by Expedia. Apart from the column is booking, representing the booking outcome. These features are research parameters which may influence the choice of hotel reservation, like historical price, customer star ratings, geographical location relative to city center, and so on. For better decision making, we did some exploration to take a deeper look. The dataset size is very huge, which will make this problem a little bit challenging to work with. Firstly, we observe the number and percentage of missing values to decide what kind of data cleaning strategy will be used later. Before we move on to creating a better algorithm, let's see if anything correlates well with each other. We plotted the heat map of features. This could tell us if we should dive more into any particular columns. We can find that there are few parameters have strong linear correlations with hotel cluster. Unfortunately, this means that techniques like linear regression and logistic regression won't work well with our data. The first step in applying machine learning is to generate features. There is another dataset called destinations, which collected hotel research talent attributes. We can generate features using both what's available in the training data and what's available in destination data. Destination data set contains 149 columns of talent information about its destination. We need to compress the number of columns down first. To minimize runtime, we can use PCA to do this, because PCA reduces the number of columns while trying to preserve the same amount of variance. To balance the number of columns and information loss, we plotted the PCA map of search destination ID. From this picture, we decided to compress down to 3 columns in our data so that we can preserve most of the variance in destination but save a lot of time.
Hello. Next part, I will introduce data processing. First thing is data cleansing. Our dataset comes from cargo. After data analysis, there is no obvious errors in dataset. So we only need to fill the numerical data with 0. And the missing time data, we converted them to year, month, day, and fill them according to common sense. Such like we will fill months with 7. Next, we did feature selection and engineering. Considering the numerical data, we use them directly, and the time data, we compute the gaps between 3 data times as future, and remove the original columns. We also need to merge destination set with train set, use the KID of the place. In this project, we only use the data contents book event, so we will remove the click event. We will be predicting which hotel cluster does a user will book after a given search. We submit the result to Kaggle and map at 5 score for the evaluating. Map at 5 means that we need to make 5 hotel predictions for each user, and finally form a list, a cluster list. The result be scored by on whether or not the correct prediction appears in our cluster list. In this way, our strategy is using machine learning models to predict which hotels are mostly likely to be booked by users, its probabilities. We're not directly predicting cluster of hotels. Finally, we select the top 5 hotels with highest probabilities to form cluster list, which will generate the final prediction result.
Hello everyone, I'm Hu Yifei, and I will introduce the machine learning model we used in this project. We use 3 machine learning models in our project, and we try to combine them together. First, random forest. Random forest is a classifier with multiple decision trees. For each train, the training set used is sampled from the total training set using the putback method. The flowchart shows how to implement this model, and there is a module called random forest classifier in sklearn example, and we use it to build this model. Second, SGBoost. SGBoost stands for extreme gradient boosting. It uses more accurate approximations to find the best train model. It computes second-order gradients and has advanced regularization, which improves model generalization. And there is a module called SGBoost. We can use it to build this model. Second, SGD. SGD classifier is a set of algorithms that use gradient descent to solve parameters, such as SVM and logistic regression. Since our dataset is very big, so we choose the loss function to be log, which gives logistic regression. And there is a module called SGD classifier in sklearn.linear model, and we use it to build this model. Finally, we try to combine the models obtained by the 3 machine learning methods together. We save the prediction probability of each model on the test set as H5 PY fields and try to sum the probability by weighting. And let's see the results. We use different models to do prediction on the test set and submit the results to Kaggle to calculate the accuracy. As we can see, random forest and SGD has higher scores, and using combination did not bring a real improvement. The reason is we just use a very simple combination method, and the score of SGBoost is low. And there are several ways we can improve our model. There is a data leakage problem on Kaggle. The hotel cluster is almost certain with the known combination of user location, distance between departure and the destination, and the search destination, so machine learning can do little. A good way of solving this problem is to adopt the embedding technique based on the data leakage. Because of limited time we have for the project, we have only tried 3 more common models. For further improvement, we can train more models and then combine them to get better results.
Hi, this is Linzhi. In the following part, I'm going to introduce about the second approach we use, the collaborative fielding.
The idea behind collaborating fielding system is quite simple. It's based on the assumption that user with similar behavior pattern or feedback pattern would also share similar taste. So if we group all the users based on their feedback, then we can do the recommendation based on the group we made here. For example, if Alex has ever chosen a hotel from the cluster A, then we can do the recommendation of cluster A to another user in the same group, like Bob. So we first do the grouping, then we do the recommendation across all the users in the same group. And here, in order to the recommendation, we require a huge amount of data about every user, and even in all kinds of situations. We also require a huge amount of data about the hotel in every destination. But in this case, that information matrix would get two parts to fit on. And like for every hotel, we can only find a few records about it. Then we cannot do very precise recommendation in this case. So instead of using this combination information, we directly use the user's ID and cluster's ID as the object we're trying to recommend. And here we didn't use any explicit feedback since there is no explicit feedback in our dataset. So we used the book result and the clicking behaviors of the user in every hotel. In order to handle this huge amount of data, we directly implement this method on a cluster of Spark. Since in Spark, the data is split is distributed on every node, so we don't have to worry about memory overflow here. And the model is based on AIS, is also being implemented in Spark. And since we only use a very small portion of the feature here, so we don't expect a very accurate result. But the result turns out to be 18%. I think it's okay. And a good thing about this method is it doesn't involve any information leakage, since all the features involved in the information leakage actually been dropped out since we only use a very small portion of the feature. So we don't have to worry about the contamination from the information leakage on our result.
Conclusion. In this our project, our goal is to make a hotel recommending system by Expedia Hotel, including user data, hotel data, and dates and places where users stayed in hotels. Through the analysis and the feature extraction of this data, we obtain several predictions by machine learning and other method of a broader strategy for recommending Expedia hotels to users. However, the data is so huge, we first choose the cloud platform provided by Google as our operating platform. On the cloud, we loaded all the train and the test data, and using a visualization technology to grasp the data information, we also tried Spark and Azure to handle all the large scale data efficiently and intensively. After analyzing and pre-processing the data, we did a feature extraction. After that, we used different models to train the train set and data set, such as random forest, XGBoost, and collaborative filtering and the ALS model in Spark. Even making several models and doing efforts a lot, we still have many optimization solutions that have not been implemented in this project, which lead to the future work of us to better process and the data and build models for this project. Thank you so much.